This small silver disc can lift 1,000 times its own weight. Put your finger between two of them, and they will crush it like a walnut. This is a neodymium magnet, the most powerful magnetic material humans have ever created. And by the end of this video, you will see the exact moment a dead piece of metal becomes a magnet in less than 1/500th of a second. Don't skip it. It looks like magic. But first, a quick question. How many magnets do you think are inside your smartphone right now? Write your guess in the comments before I tell you. The real number is coming later in this video, and almost everyone gets it wrong. And if you love finding out how the world really works, subscribe. Every week we crack open another industry nobody thinks about. Without magnets, your world stops. Electric motors, speakers, hard drives, contactless payments, MRI scanners that see inside your body, wind turbines, satellites. Every single one of them depends on that invisible force. And yet the strongest magnets on Earth begin their journey in the most unexpected place, as gray dust scattered through ordinary-looking rock millions of years old. Humans have known about magnetism for thousands of years, ever since shepherds noticed that a strange black stone called magnetite pulled at the iron nails in their sandals. For centuries, that natural stone was all we had. Then, in the early 20th century, engineers learned to cook their own magnets. Alnico, an alloy of aluminum, nickel, and cobalt, far stronger than any natural stone. Later came ferrite magnets, cheap, rust-proof, perfect for mass production. They still live inside billions of speakers and refrigerator doors today. But the real revolution came in the 1980s, when scientists combined a little-known rare earth metal called neodymium with iron and boron. The result, the NdFeB magnet, was a monster, up to 10 times stronger than ferrite, yet smaller and lighter than anything before it. The element itself had been discovered back in 1885 by chemist Carl Auer von Welsbach, and then sat in obscurity for a century, waiting for its moment. Today, that once ignored metal is one of the most strategically important materials on the planet. And here is the first fact that surprises everyone. Rare earth elements are not rare. Neodymium is more common in the Earth's crust than lead. The problem is that it never sits in one place. It is scattered, mixed atom by atom into other minerals, spread thin across entire mountains. To get it, you cannot just dig a hole and pull it out. You have to take the whole mountain apart, and that is exactly what happens. It starts at giant open-pit mines. Engineers map the richest sections of rock. Drilling machines bore deep holes in precise patterns, and controlled explosions tear thousands of tons of mountain into rubble. Excavators the size of houses load the broken ore into mining trucks so large that their tires are taller than a man. One more fact while the trucks are rolling. About 90% of the world's rare earth processing happens in a single country, China. That is why a gray powder you have never heard of shows up in trade wars and international headlines. Whoever controls neodymium controls a piece of every electric car, every wind turbine, every smartphone on Earth. At the processing plant, the rock is crushed, then ground into powder fine as flour. But you cannot pick neodymium out of powder with tweezers. It is chemically locked inside the minerals, so engineers dissolve the problem, literally. The powder goes into baths of acid where the rare earth elements leach out of the rock and into the liquid. Then, through cycle after cycle of chemical separation, 17 nearly identical rare earth elements are teased apart, one by one, until pure neodymium finally stands alone. A chemical base turns it into a solid again. Furnaces roast it into neodymium oxide. And what is left is a humble gray powder sealed into steel drums. It looks like ash. It is worth more than nickel, and every drum of it is already promised to a factory somewhere in the world. Now comes the part I love. At the magnet factory, the neodymium is melted together with iron and boron. But there's a catch. At high temperature, neodymium reacts violently with air, expose the molten metal to oxygen, and it burns. So the entire melt happens inside a vacuum induction furnace, a sealed steel chamber with the air pumped out, where invisible electromagnetic currents stir the metal as it melts at over 1,300 degrees Celsius. Molten metal floating and swirling in a sealed chamber, touched by nothing but magnetic fields. The alloy is then cast into molds. And in traditional foundries, this moment is pure theater. The sand molds are hardened with a flammable gas, so when the glowing metal pours in, the molds catch fire. Workers then knock the castings out and slam them with sledgehammers to shake out trapped air pockets. Flames, sparks, hammers, and out of all that violence comes a dull gray block of metal. And here is the twist nobody expects. That block is not a magnet. You could hang it on your fridge and it would fall off. It has the perfect chemistry, the perfect crystal structure after careful heat treatment in sealed, oxygen-free tubes. But its magnetic domains, billions of microscopic compass needles inside the metal, are pointing in random directions. They cancel each other out. The magnet is asleep. Time to answer the phone question. Inside a modern smartphone, there are, on average, more than a dozen magnets. Some engineers count up to 20. The speaker, the vibration motor, the camera's image stabilizer, the compass, wireless charging, magnetic mounts. Did your guess come close? Write, "I was right," or your number in the comments. And now, the moment I promised you at the start. The sleeping metal block goes into a magnetizing fixture, a coil connected to a bank of capacitors storing a massive electrical charge. Then everything fires at once. A single pulse of current, millions of watts, slams through the coil and creates a magnetic field thousands of times stronger than the Earth's. In less than 1/500th of a second, every one of those billions of microscopic compass needles snaps into alignment, all pointing the same way, and locks there, held by the crystal structure itself. One flash. That's all. The gray block that couldn't hold a paperclip is now a neodymium magnet that can lift 1,000 times its own weight, and it will hold that power for decades. And that power deserves respect. Two large neodymium magnets attract each other so violently that they can leap across a table, shatter on impact, and send razor-sharp fragments flying. Factory workers handle the big ones with wooden spacers and steel gloves. And these magnets have one secret weakness: heat. Warm a neodymium magnet past about 300 degrees, and its domains scramble back into chaos. The strongest magnet on Earth dies quietly in a kitchen oven's hottest setting. From here, the finished magnets spread out into everything. A single electric car carries about 2 kilograms of neodymium magnets in its motor. One large wind turbine can hold hundreds of kilograms in its generator. Headphones, drones, robots, satellites, all powered by a gray metal nobody had a use for a century ago. So the next time a magnet snaps shut on your fridge, remember what you are actually holding: a piece of a mountain blown apart by explosives, dissolved in acid, melted in a vacuum, hammered out of a burning mold, and brought to life by a single flash of electricity, 1/500th of a second long. Invisible power made by human hands. If this video earned it, hit that like button and tell me in the comments which everyday object we should tear apart next. Subscribe, because next week we crack open another industry nobody thinks about. See you there.